A vessel traffic system, VTS for short, is responsible for ensuring the safety and improving the efficiency of maritime traffic. A VTS site like this one in Zhuhai, in southern China, mainly relies on radar to monitor shipping movements. The system detects the course, ID number, and location of moving ship, guiding them to vastly improve navigation efficiency. To put it simply, the primary function of a VTS site is to ensure the safety and boost the efficiency of maritime traffic. For such sites, the reliability of the power supply is paramount, since it serves as the basis for all systems and equipment to operate. If the power supply isn't reliable, equipment can't function properly and is unable to provide critical services 24 hours a day. In the early days, because our island is isolated and had no electricity, we had to rely on 2 diesel engines for power generation, with the UPS performing the subsequent discharge. Altogether, the diesel generator operated for 10 hours and the UPS ran for 14. A major problem with the diesel generator was its low energy efficiency. It consumed an enormous amount of diesel, which had to be regularly transported to the island. And to prevent any potential power interruptions, UPS batteries had to be replaced periodically. Add in associated staffing costs, and the overall cost was high. It was already 100,000 Chinese yuan per year. That's over 15,000 US dollars. Clearly, fuel consumption was substantial, and it accounted for as much as 25 tons, or even more, of carbon emissions each year, according to our estimates. This pollution was obviously harmful for the environment. So it was evident that the power system we had was inadequate for long-term development from both an economic and an environmental perspective. We all need to think beyond the short term and embrace the use of green energy. We have also used other PV systems before, but we had to replace them with Huawei solution. Why? First of all, the other PV systems did not support multi-energy access and management. This is still a critical weakness of many PV systems on the market today. Let me give you an example. When energy generated from PV is low, a traditional PV system cannot intelligently determine. Our previous system lacked this function. So we had to modify our machines to enable the automatic startup of the diesel engine. In addition, most PV systems still use lead-acid batteries, which age quickly, affecting the accuracy of battery capacity. And even making many modifications, the legacy system did not work well. Indeed, overall, we can say that traditional PV systems are unfit for operational needs. Huawei's power system is something different though. In many ways, it's much more advanced than everything else in the industry. First of all, it's very efficient. We have already seen vast improvements in the conversion efficiency of PVs. In addition, inverter efficiency is much higher than that of conventional UPSs. Most importantly, Huawei solutions offer an array of AI functions. Take the multi-energy management function as an example. When power generated by PV is weak, the diesel engine will automatically kick in to provide more power, stopping when it's no longer needed. This achieves the dual goal of reducing the use of diesel fuel and protecting the environment. The system's modular structure also offers many benefits. Deployment is flexible and spare parts are readily available. Instead of whole equipment sets, modules now serve as spare parts. Another highlight of this system is that it supports multiple power specifications. For example, 48V DC, 220V AC is supported. This system is also compatible with many kinds of device, such as CCTV. It will also support seamless access to the main supply, thinking further ahead, future-proofing all of our investments, and ensuring a smooth transition in the future.